Okay, college algebra students. Apparently, we didn't finish all of this lesson on graphing other functions. In 1A, we got as far as trying to make a table of this greatest integer function. And I was in the middle of explaining how look at all these values that are still a -1. Or a 1, whatever that number was. Yeah, because we were doing negative numbers. The easiest way to do these is to realize is that this is just a linear equation. And we know that when x equals to 0, it's where my y-intercept is. So 1/2 times 0 plus 1 is 1. There has to be a point at that ordered pair, 0, 1. Has to be a point there because it's an integer. So the line you're creating looks like the line that has a slope of 1/2, y-intercept of 1. So that would be, a slope of 1/2 would be up 1 over 2. That point also has to exist. Up 1 over 2. See, did I half blind here? Up 1 over 2. Yeah, I was way off. Let me do those both over again. It makes it more sense when you zoom in. So try that again. Up 1 over 2. Up 1 over 2. Up 1 over 2. Up 1 over 2. And that didn't go over 2. I can't count. Even when I have it zoomed in, I'm still blind. Up 1 over 2. Up 1 over 2. Up 1 over 2. Up 1 over 2. Let me go the other way. Down 1, left 2. Down 1, left. Down 1, left 2. Okay. So there's enough there to get the idea. And you'll notice that we were looking at some negative numbers like -4, -3.5, -4.5. And if you look, all those numbers have to be on this bar right here until I get to the next integer where I put an open circle. That's why all these values here was a -1. That's an awful lot of numbers that give you the same height. So I run this over to the step to the next integer, and that's going to be, has to be open, 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 open. I don't have to do them all. The idea is there. I mean, you could do them all just because you're just that kind of person. Down 1, left 2. Down 1, left 2. Down 1, left 2. How convenient. It finished the whole graph. And then, again, horizontal till you get to the next one. Horizontal to get to the next step. Horizontal to get to the next step. And there you go. There's the whole thing. That's the easiest way to graph because you see there's so many numbers that are in between. It's a whole unit of 2, so all the numbers in between would always give you the same. You would need to get lucky, and realize what's happening. To me, that was the best way of graphing it. Applying a greatest integer. An express mail company charges $25 for a package weighing up to 2 pounds. So that means any package up to 2 pounds, even if it was 0.1 pound, it's still going to cost $2. Even 0.5 pounds is still going to cost $2. Even one pound is still $2. Up to $2, up to 2 pounds is still $2. 0 pounds probably don't cost anything. So at 0, there's not a point. It's everything to the right. That step here is all $2. What else do I know? For each additional pound or fraction of a pound, there's an additional charge of $3. So if I go to another fractional pound, even up to 3, he's adding an additional 3, so that would make it $5. $5. So at 3, you're paying $5. Less than 3 until you get to the 2 is still $5. But at 2, it's only a 2. That's why that one gets the solid. That one got the whole. So do you see what just happened? Do you see the pattern? Was there anything else? Let y equals d of x represent the cost as in a package weighing x pounds. Graph y equals d of x, and x is the interval 0 to 6. So what's happening, it looks like every additional pound, you're going to go up another $3. So that was 2 to 5, 6, 7, 8. So that's going to be solid, open. At 5, 8, 9, 10, 11. So I'm going to go up here and go to 11, open. At 6, that takes you to 11, 12, 13, 14. That takes me to a solid at 6, open. This was solid here. So that's my best picture. The greatest integer? There's one thing off. I needed to number my y value. This was not, what did I say, $2? It was $25. This was $25 at that. Then he went up 3, that'd be $28. This is the 28 to 9, 30, $31. 32, 33, $34. 5 to 6, $37. The last one up here, $37. So $38 up to 2 pounds, then up anything from the 2 pounds to 3 pounds is $28. And then, let me make sure I added right, 28 to 9, 30, $31 up to 4 pounds. 31 plus 3 is $34, $37, yeah. That's where I'm gonna leave it at. I think that's pretty good. Okay, last thing. X equals y squared. It should not be a surprise to you that in the past we could have solved for y and said if x equals to y squared, I square root both sides, but whenever you square root both sides, it's plus or minus. So y is actually plus or minus the square root of x, which means positive square root, negative square root. That's what that function is. And it's not a, I'm sorry, it's not a function. It's not a function, it's a relation because it fails the test, the vertical line test. So recall that a function is a relation where every domain value is paired with 1, with 1, probably, well, 1 and only 1, and only 1. Range value, there you, that'll work. I think that'll work. 1 and only 1. Every x only has one y. That's what that means. So it's not a, this is not a function. That's what he's saying. So if you make a table, this time plug in the y's first. 0 squared gives you the x, which is 0. Plus 1 squared gives you a 1. Minus 1, if you square negative 1, you still get a 1. So plus or minus doesn't matter. So if you look at all these ordered pairs, you got 0, 0, 1, 1, 1, negative 1. If you put in a 4, now you don't plug that 4 in, you plug in the 2. Plug in the 2, 2 squared is 4, negative 2 squared is 4. So we have 4, 2, 4, negative 2. And 3 squared is 9, and negative 3 squared is I messed that up. I'm so used to writing X's. So are you probably. I'm plugging in the 3 here to get the 9, and then a negative 3 here to get the 9. Okay, so if you plot all those points, 4, negative 2, 4, down 2, 4, up 2, 0, 0, 1, up, 1, up 1, right here, 1, down 1. So you get the point? See what's happening? You're getting the sideways parabola, which is a copy, a reflection of the square root function. That's the square root of x. This is the opposite of square root of x, so it's negative. Even your calculator would give you that, but in your calculator, you'd have to graph it as two problems. In your calculator, you can't graph x equals, you gotta graph y equals. So you'd graph y equals square root of x, y equals negative of the square root of x, and you'll get this picture. The domain starts here, goes forever to the right. So it can be 0, and it goes to infinity. The range goes up forever. In the future, this goes up and up and up and up. This goes down and down and down and down. So we would say from negative infinity to infinity. And I just talked to you how would you use a calculator. And take and hit save and record and upload this so you can finish the notes. And your homework is due tomorrow because it's all lectured. Adios. Me to the next lesson. So let me go.